Good morning, good evening, or good afternoon, everyone. Really appreciate you guys joining us today. We're super excited to spend some time with you. My name is Sandeep Brahmaruthu. I am a business development manager on our Database Freedom program at AWS. And I'm joined here today by my colleague, Craig Silveira, who is the Database Freedom technical team lead. Together, we will focus today on talking about an exciting topic around assessing, migrating, and modernizing from legacy databases to AWS. And we'll specifically focus on how to migrate a database from Oracle to Amazon Aurora. So we've got some really key points that we want to touch on as we kind of go through this. So from an agenda perspective, we'll quickly touch on why are people interested in doing this type sort of migration, right? So what are some key business drivers that we're seeing in the market that are driving our customers to consider migrating from an Oracle to Aurora? We'll quickly talk about the common migration paths in terms of migrating an legacy database like Oracle to AWS. We'll touch on some of the migration tools that help our customers in this migration process. We'll spend bulk of the time today really talking about and showing you the demo of an Oracle to Amazon Aurora, especially the Postgres version from a migration perspective. And then we'll touch on some resources and open up for Q&A. So lots to cover today, so let's get to it. So what are some high-level drivers that we're seeing from our customers that's driving them to consider a migration off of a legacy database like an Oracle to Amazon? So at a very high level, we're seeing sort of three main key trends as it relates to data and the requirements around modernization. The one is explosion of data. So as data continues to grow, customers are storing all different types of data, and they're looking for ways to capture that data and drive the appropriate insights for their business. That obviously has an impact on having the right data platform that can scale and support these new requirements. Second is around microservices and changes associated with microservices. It's no longer one size fits all when it comes to databases, where in the past you may have one monolithic large database that sort of serve a variety of different use cases. With microservices, customers are now looking to effectively take that monolithic databases and really sort of fan those out to very purpose-built database engines that's really specialized to handle the right type of workloads and use cases. The third is around accelerated rate of change driven by DevOps. Customers are iterating much more faster and quickly in terms of how they're developing their applications and how they're serving their customers, and they need data platforms that can help, that can support that DevOps, the fast rate of iteration from a software development perspective. So at a very high level, we're seeing these data requirements really putting a light on, how customers are thinking about, migrating and modernizing their legacy database platforms. Combine that with, what are some, other things that are impacting your customers when they think about legacy databases. With legacy databases, our customers are faced with high cost of expanding and maintaining these legacy platforms. They're looking for ways to reduce costs and avoid future costs. They're looking to get away from proprietary features, right? A lot of these legacy platforms have proprietary features that may be stored procedures, triggers, functions, and they're looking for ways to sort of unlock themselves from these proprietary features and really leverage some of the innovation that's happening in the open source database world, as well as cloud native databases. Lastly, we hear this time and time again from our customers, is that they are really looking for alternative ways in terms of how they license their software, right? They're looking to get away from punitive licensing tactics for some of these vendors, and also plan for alternatives, especially when they're faced with an audit mechanisms deployed by some of these legacy vendors. So at a very high level, right, there are modernization trends that we're seeing in the marketplace, but also if you combine that with some of the practices of these legacy database vendors, customers are truly looking for different ways to drive and deploy their databases on. So we're seeing customers move to open source databases. MySQL, Postgres, MariaDB. These are some of the examples of platforms that we're seeing a strong traction of our customers moving off of legacy platforms to these open source databases. But these platforms, customers are still don't want to sacrifice the commercial grade performance and reliability that they're accustomed to with these legacy platforms, right? So as a result, customers are looking for options where not only are these open source databases, but they also want that performance and availability features that they're accustomed to. And we'll touch on some of those here in a second. So really, from a benefits of moving to AWS is that we have a variety of different database options to help our customers that are open source and cloud native. These benefits that we're able to provide to our customers are around increased agility. So customers no longer are tied to these monolithic architectures, which becomes very difficult to iterate and develop faster. AWS databases offer really compelling cost benefits, especially as it relates to adopting our open source databases, reducing cost, coming off of legacy vendors. The performance and scale associated with AWS platforms are extremely compelling, especially as your needs change in terms of you want to add more capacity, you add more databases, right? It's very, very easy to do so, and also choosing the right sort of instance types to help drive that performance needs that you're looking for. And because of this flexibility and this agility, our customers are now able to innovate faster, right? So these are some of the very high level benefits. Something for you to consider as you're thinking about what are some drivers and reasons why you should consider to migrate off of these legacy platforms. So we have over 200,000 databases that we've migrated onto the AWS platform since our database migration service has been deployed over the last 4 or 5 years. Here's some of the logos of our customers that have leveraged our service and tools to really do these sort of migrations off of on-prem databases to the cloud, and we're super excited to continue to innovate and add functionalities and features to our database migration service platform to make this process as seamless as we can. And we'll touch in more detail later in this presentation via Craig on how to use the tools to make these migrations successful. So now let's talk about the options our customers have to break free from these legacy platforms, right? So what are some common migration paths to AWS databases on the cloud? So if you look at, at a high level, there are multiple options our customers have to migrate their databases to AWS. So our customers can choose a very much sort of a lift and shift option where they effectively are running their existing databases as they stand today on premise, and they're running it on the AWS cloud, right? And we kind of refer that to as rehosting or lift and shift. You're not really breaking free from your legacy databases, but you're using the AWS platform from an EC2 perspective to run those databases as they were running on-prem. Right? Increasingly, we're seeing a lot of our customers leverage our managed platforms so that we're able to provide the auto provisioning, the backups, the recovery, and the patching, the updates. Really kind of take on some of the undifferentiated heavy lifting and managing a database is provided by AWS, right? So we have, we refer that to our RDS platform, and we're able to manage commercial engines as well as open source engines in that from that platform perspective. However, a lot of our customers are really looking to modernize. They're looking to break free from these legacy databases, and that's really where most of our customers are focusing on. Is that they want to reduce these licensing costs that we talked about before. They want to reduce the dependency on these proprietary features, and they want to avoid the punitive licensing tactics. So that's where we're seeing significant adoption of open source solutions by our customers. customers are leveraging platforms like Aurora that has options of both in MySQL as well as Postgres, as well as some of our cloud-native databases like DynamoDB and Redshift, right? Really driving faster innovation. And our strategy at AWS from a database perspective is to provide the right purpose-built database engine for that particular use case. No longer is one size fits all, where you have a variety of different data models sitting in a particular monolithic database engine. With AWS, our customers have a plethora of different options, whether they be relational, non-relational, purpose-built. Those options are available depending on the use case. Our customers are able to kind of pick the right engine for that workload. For the scope of today's presentation, we will focus primarily on Amazon Aurora as a destination on AWS. We see that as a common destination path for our customers, especially coming off of Oracle. With Amazon Aurora, as I mentioned, there are a couple different compatible versions of Amazon Aurora. One is the MySQL version, the other one being PostgreSQL. Both are relational. They're really built for the cloud, right? We've taken these open source engines, we've added the enterprise grade performance and availability, and really at a tenth of the cost, right? So providing that significant performance gains and availability gains at a very attractive cost savings. Some of the advantages associated with Amazon Aurora include performance and scalability, availability and durability. So you're not sacrificing that by going away from a database like an Oracle to Aurora. But that fault tolerant, self-healing, multiple copies of data across multiple availability zones, highly secure, right? That's a key tenet of Amazon services, as well as the fully managed service associated with RDS. So our customers no longer have to do the server provisioning themselves, the patching, the setups, the configurations. All of that is taken care of by our managed service. So what does a typical journey look like for our customers in achieving that database freedom, right? That freedom off of legacy platforms to our open source and cloud native database options on AWS. So at a very high level, our customers generally go through a process of assessing their existing database environment. How many databases do you have? What features in that legacy database are our customers using? How much stored procedures do you have? Like, what are the dependencies between the application and the databases? So really understanding and doing a detailed job or assessment is extremely critical for our customers so that they can then determine the right migration plan, right? And that's where our customers are sort of going to a mobilized phase of figuring out and having the right sort of framework in place for the actual migration itself. This is where customers may start off with the initial smaller scale migration, and then go into a large scale migration and take that into production, right? Especially where you have multiple databases and applications. This is where you want to deploy. A lot of our customers are looking to deploy sort of a repeatable pattern to migrate and modernize. So this is at a very simplistic level what we see as a process, and now we'll get into the specific the tools and the demonstration of an Oracle database to Amazon Aurora. With that said, let me now hand it over to Craig Silvera to walk us through the migration tools.
Thanks, Sandeep. As Sandeep just described, I'm going to take you through using two of our migration tools and understanding where they play into the whole migration journey. Specifically about the assessing, the mobilize, and the modernize and migrate phases. The tools that I'm going to be talking about are the first one is the AWS Schema Conversion Tool, or SCT for short. This is the tool that you're going to use to actually convert your database schemas and any code that exists in your existing source databases to a new AWS engine. And today we're going to be talking about and demonstrating an Oracle to Aurora Postgres migration. So we'll take a look at how to use the tool to assess and then actually convert the schema objects over. The second tool that we're going to be looking at is the AWS Database Migration Service, or DMS for short. This is a great tool that is used very often in migrations because it allows you to take a snapshot of your data from your source databases and move it over to a new target database, and this supports heterogeneous databases, so you can move from Oracle to Aurora Postgres very easily. Now, there's a second capability of this tool that's going to be very useful if you have the need to do near zero downtime production switchovers after you've completed your migration, your conversion activities. Now you're getting ready to launch this thing into production. You obviously don't want to take downtime. Most systems today require to be up 24/7. So there is a change data capture mechanism capability within DMS that allows you to do CDC between Oracle and databases like Aurora Postgres. So it facilitates that quick switchover and minimal downtime migration. Where each of these tools fit into the migration process, is shown here on this slide. So the first step, where you're assessing your environment, trying to find the good migration candidates, and we'll talk about some characteristics to look for before you even run SCT. But once you've identified some particular applications that you might want to migrate, you'd use the schema conversion tool to run an assessment report. The assessment report is going to highlight things that can't be converted automatically. So I'm going to walk you through that live, showing you how to generate the report and then looking at the information that the report is providing you. Now, after you've run the assessment and you've chosen that it's time to go ahead and do an actual conversion, whether it's a POC or an actual migration, if you're converting heterogeneous database conversion, you're going to use schema conversion tool to convert the objects, because we're going from Oracle to Postgres. It's going to change the syntax, the DDL, and the code, the PL SQL over to the target database platform. All right. If by chance you were looking to do a lift and shift type of migration or a move to manage, as Sandeep had mentioned earlier, you'd use native tools to do that. If I was going Oracle to Oracle, right, there's no reason to use schema conversion tool. You just use one of the native tools, which is just another path you could choose. Finally, after you get the structures converted over, you're going to want to move some data. Initially it's for testing, but then of course, when you're looking to switch over to production, you'll have to get a synchronized latest copy of the data, and then move that over. So, for traditional OLTP type systems, you're going to use our database migration service, as we're going to demonstrate today. For data warehousing environments, if you're moving that data, schema conversion tool has something known as data extractors that work with source databases such as Teradata and Netezza to move that data over to a AWS database such as Redshift. All right, so let's talk about that workload qualification framework. When I talked about, you use SCT to do the assessment, but before you even get there, you have to, think about all your database landscape and identify the types of applications that you think are good candidates for this migration process. So to help you along, we've created some guidelines, right? We call it WQF, and there's 5 different categories that are defined in the WQF. And the whole idea is just to kind of, quickly disqualify certain applications, right, that you may not be able to move. So if we start at the bottom, we're talking about WQF Category 5 applications. These are typically third-party applications. A company, let's say like SAP, has an application that supports a few databases, right? And if one of the AWS target databases is not one of those supported databases, you're not going to be converting that application, right? Now, you may want to completely switch out that application for a different application that supports other databases, but that's a much bigger project. So initially, you'd look at that as a non-portable application. You wouldn't focus your effort on that, right? The other 4 categories are, applications that you'd want to start thinking about in migration, right? And as you can probably guess, the lower the number means the easier migration that is expected, compared to a higher number that is going to be more work. So category 1, for instance, those databases are generally very simple. They might just be data stores. If there are some stored procedures, there's very few, or they're very simple, right? Because most of the business logic for that application resides in the application layer. But those applications are generally very database friendly. It might be something like Java, which it's very easy to port a Java application across multiple database engines, right? So that would fall into category 1. As you go up, obviously the complexity, there's more business logic that resides natively in the database, and of course it gets more complex. And then you also, on the application side, get into some more legacy type of applications. Maybe it's something like in the Oracle world, a C-based application that uses Oracle's Pro-C precompiler, right? There are precompilers in the Postgres world, for instance, but it takes more effort, right? Because there aren't tools that automate that conversion, right? But we at AWS, we have experience helping customers do those migrations, right? You'll get to a category 4, and category 4, as you see, it says engine-specific workloads. So if you're using an application that uses a tool, a classic example is something like Oracle Forms for any of the folks that have been around using Oracle technology for a while, right? Forms is a very database-centric and a proprietary Oracle application framework, right? So those things are very difficult. You can't convert that as is and have that Forms application work with a non-Oracle database. So you really need to convert that Forms application to something more, database friendly or database agnostic. And there are some tools that will automate conversion of forms. So let's say Java-based applications. And then there's a whole bunch of logic at the database level that sits in Oracle Forms that is directly related to the application. If you're converting the application, some of those objects go away, but then there's customizations that you'd have to convert over to the database. So it's definitely possible to migrate this category, but it is going to be more work. So when you're planning out your migration, you're going to start with the lower level categories as you build your migration muscle, right? And you build your knowledge base and your skill set. So when you start, you get down the path of your migration journey and you start tackling category 3s and category 4s, you've been through this before, right? And therefore, that's going to make those projects move along much more smoothly. All right, so enough talking. I'm going to be jumping into the demo, but before I do, here's the demo setup. All right, we've been talking about migrating an Oracle source database. So I've got an Oracle source database that has a whole bunch of database objects. We'll look at how you use SCT to assess that. We're going to a Postgres target. So after we run the assessment using SCT, I'll show you how you can use it. It's like any other IDE. You can make changes directly in the tool. And then after we get some objects created over in this target Postgres database, we're going to use DMS to set up a replication task to take a snapshot of the data and place it in our target Aurora database. So with this, I'm going to change my screen and jump into the demo. Okay, the first step in this migration process, as we've been talking about, is to assess your existing source databases to understand, what the complexity of the system is, and then what type of effort would be necessary to get it converted over to the target platform. So for this, I'm going to use the schema conversion tool. I'm going to come in here. If this is the first time you're launching, a wizard's going to pop up. It's very similar to what you're going to see here. So you can access it via the new project wizard. All right, I'm just going to click on new project. You can give this any project your name. I'm converting a transactional database. It just the different choices here change the options of the databases that you get to choose below. For our case, I'm using an Oracle source database. I'm going to convert it to Amazon Aurora Postgres compatible version. So I click OK. And now what I have to do is I got to connect to that Oracle database. So you're going to provide it, the proper connection information and password to get this project started. Click OK. It's obviously going to reach out. It's going to connect to the database. It's going to gather some high-level metadata information. So here's a view on the left-hand side of what's in my Oracle database. And you can see there's a lot of stuff here, and it's a little bit cluttered because their system scheme is in here. So one of the first things that I typically do, and you can customize what this project looks like by adjusting project settings. So if I go over here to project settings, right, what I see in this tree is configured by this tree view, and I don't want to see these system schemas. So I'm going to check this. I'm going to hit OK, and now I'm focused. My view is the user-defined schemas that exist in that Oracle database, because those are the ones that you're going to be converting over. All right. For this demo, all right, I've got a bunch of schemas here, but I'm going to focus on one schema, which is my DMS sample schema. If I expand this out, right? It goes and it gathers additional metadata about the objects in there, but I can see I've got 16 tables. I can look at what the definitions of the table is. All right, so if I can see my constraints, just thinking, there we go, there's our definition of the table. Okay, so I can browse through all my source database objects. Now, what I really want to do is I want to create this assessment report, and it's a very simple process that I can either go to the actions menu once I have the schema highlighted as I do down here, or I can right click and basically choose the same thing, which is create report. So when I do that, what the SAT is going to do, it's going back to the database and it's really doing a deep dive in the metadata that defines all these objects. So it's looking at the DDL statements, it's looking at the code, the PL SQL code in the Oracle database, and it attempts to convert those objects behind the scenes. That's how it's going to produce a report. So this is going to take a couple minutes, just so we can, in the interest of time, I have a pre-created report that is based on the same exact DMS SQL DMS sample schema. So you see, here's the schema name, right? And there's different parts of this report, all right? Just to get a gut feel for, how difficult it would be to migrate, you're going to start with the executive summary. In this case, we see that 100% of the database storage objects, and that is defined as the tables, the constraints, and indexes, they convert over without any issue over to Aurora Postgres. And then the next number, 96% of the database code objects can be converted automatically, right? These are really good, conversion rates, right? So we really want to understand, what is the detail behind that 96%? What is the 4% of code objects that didn't convert? And that's going to be shown later in this report, right? First, there's some graphs that kind of show, there we go. You see SET just completed the assessment, right? So what we were just looking at is if I took this, right now I'm inside of the tool, and if I click save to PDF, that's that file that we were just looking at, right? So you can look at it either way. Obviously, if you save it as a PDF, you can send it via email to your colleagues so everybody can be looking at the same thing. But let's just jump back into the tool so we see, how it's presented here and how you're going to use the tool to continue with this migration process. So again, here's the high-level summary, the graphs that we just saw in the PDF report showing that there was no issue with the database storage objects. But there was an issue with it turns out to be one package procedure here failed to convert automatically. There were a couple things that are converted with simple actions. To understand what those are, you would go click on here, and if you're in the tool, to action items. And now I see the errors up here in the middle, right? So I can look at, for instance, if I look at this procedure that failed to convert, and I see the error being the syntactic element conversion is not supported yet, this highlights the piece of code that caused the problem. All right. Now we're going to look at that when we convert it over to understand a little bit more what the case is going on. But these other issues, the fact that they're gray exclamation marks, are more warnings than errors, right? So these particular things shows that there's a hint being used that isn't supported in Postgres. Now, Postgres supports hints, but you have to enable it. It's an extension, right? And you're not going to expect hints that worked in Oracle to work the same way in Postgres, right? The good news is that these hints that might not be supported in Postgres are treated as comments. So there is no action necessary on your part for this, right? It's only when you decide that you need to use a hint, then you're going to enable the extension on Postgres and use that hint in the SQL statement. This other warning is just telling you that converted functions depends on the time zone setting. So it's very important that when you create your target database, that you map it to the same time zone that you were using in your source database, right? To make sure that matches, so then, of course, the results of these functions would be correct, right? Again, more of a warning as a heads up, watch out for this. All right. So the next step here, I understand the issues, and now I want to actually convert it and see what happens with that. So I'm going to come over here, right-click on my schema, and I'm going to choose. Oops, you got to connect to your destination database, otherwise it doesn't know what you're converting to. So in that case, let me just connect to my Aurora Postgres database. When I do that, you'll see on the right-hand side a similar tree for my target database. And now I can go back here. I can either right-click or I go to the action. So I'm going to convert this schema. Okay. So now I see I've got my schema that this is not in the database yet. This is all done within the tool. I can expand out. I can see here are the tables, all right, that have been converted. So if I click on the one table, I get to see here's my source DDL. Here's what the target DDL looks like. Right. So very easily I can in the tool, and if I had to change something, I can change it here. Then I can go apply that to the database. So that's the next step, right? Once I get things converted within this tool, I need to take the results of it and go apply it to the database. All right, so over here, what I'm going to do is I've got to unselect all these other schemas. I'm only interested in the DMS sample schema, but specifically, just for the interest of time, I'm only going to move to tables. The tables are necessary for the next step of using DMS. And what we always recommend when you're approaching a migration is do it in two steps. There's the structure step. Get that over, because you need to get the tables created and get data into those tables, because as you're converting and fixing stored procedures that are converting over, you need something to test with. So do this in a two-step, and just it'll just make your life a little bit easier. So in this, now that I have this, right, what I want to do is apply this to the database. Okay, so I click apply to the database. I say go check on it. And now it's running the DDL to create those tables against the Postgres database. Now, you can use whatever tool you're most comfortable with. I'm going to use a tool called dbeaver to go out and take a look at this. All right, so if I'm down here, let me just refresh my schema. That's what I expected. I got to reconnect to my Postgres database here. Okay, now I've been reconnected. I can expand out my tree. I can look at refresh my schemas. And now I see here it's still doing the creation of the schemas. You're going to see a couple called AWS_Oracle. These are supporting packages or schemas that the schema conversion tool creates to support the conversion of the objects. Now you see how the focus was brought back to SET. So SET finished doing its thing. If I go back to dbeaver and I refresh my schema list one more time, I'm going to see my DMS sample schema. And if I expand this out, I'm going to see that I have tables over here, right? And now what I might want to do is just verify I have no data in these tables right now. I can go over to the source Oracle database here. I've got my session here. Let me run this, and you can see I've got 2,230 records in my source Oracle table. So now I've got to move them over to the Aurora Postgres instance, and for that I'm going to use the database migration service. So let's go jump into that. All right. When you're setting up the DMS, right, you've got to first launch a replication instance. Think of this as the tool that kind of sits between your source database and target database and controls the migration, right? So you would go in here and you'd create a new replication instance. Now, depending on the size of the instance, and that really depends on how much data you're going to be pushing through, the creation of this can take a few minutes. So I'm going to use one of my pre-existing ones. This is my DMS Lab replication instance. The next thing that you have to do is you have to define endpoints, right? This is given the connection information to the source database and the target database. So I've got my endpoints defined. You could easily create your new endpoint, and you specify like what type of database it's going to be, so DMS is aware of any data type conversions that have to happen. So I'm going to use my Oracle 12 database as a source for this demo, and I'm going to use my Aurora Postgres database as the target. Okay. Now, the most important step here is that once you get that plumbing work done, you're going to define a migration task. The task is what tells DMS what to do, right? What objects to, copy the data over, how to copy it over, and so forth. So we're going to be defining a new task. You can see I already have a couple tasks defined here, but let's take a look at the steps required to create a new task. All right, the first thing that you're going to do is give it a unique identifier. I'm going to call this webinar task 2. I'm going to choose the replication instance I'm going to run this task on, and as I mentioned earlier, that's the DMS Lab replication instance. I'm going to then choose my source and target endpoint. So I've got my Oracle source database. I have my Aurora Postgres target database. Now, migration type. This is the first time you're doing a migration. What you're going to do typically is migrate existing data. If you were setting up CDC on systems that already exist, you choose replicate data changes only. If I'm doing both in one shot, it would be the second option here. All right. Now, just a little thing just to make so I can explain what's going on, but I also recommend uncheck this start task on create. It gives you a second to breathe after you create this to get familiar with the environment, right? We can start the task at any point after that. All right, the task settings, a couple of the important things that you want to do. All right, we converted the schema using SCT. So our tables, as we saw, the structure of the table exists already. If that wasn't the case, DMS could actually create those tables for you, all right? But we're dealing with a big migration. We're going to break the steps up, all right, just to keep things clean. So in that case, I don't want to do anything. I don't want to drop the tables. I don't want to truncate. We know it's already empty. So I'm going to select do nothing for this first step here. All right, if you have lobs, there's different ways of migrating the lobs over for performance reasons. All right, another very important thing, I mean, you could choose enable validation. So we basically check checksums of the data where we're pulling it out of the source, and then when we bring it over to the target, so you can feel comfortable nothing's been tampered with, right? But most important is make sure you enable CloudWatch logs, right? Because if you don't do this and something happens with DMS, you're going to have to go back and enable this and and then rerun the test to figure out really what went wrong. If you do this, you get access to the logs via CloudWatch, and you can see what DMS is doing at any step of the way. All right. Now, table mappings. There's two different ways to do it. There's the guided UI, which you're going to use when you first start out with this. When you get really good, you'll just probably create JSON templates and just paste that in here, right? So there's two steps to the table mappings. First, you got to tell it, what objects to actually migrate. All right, so I'm going to add a new selection rule. I am going to be very specific. I want to migrate a specific schema, and inside of that schema, I'm actually only going to migrate tables that have the name underscore data in its name, right? And so I'm saying let's include those tables. So that's about 5 tables in my system. All right. The next step that you need to do is add some transformation rules. When you're going from Oracle to Postgres, this is very important because metadata about Oracle objects are stored in uppercase in the data dictionary. And in Postgres, it's stored as lowercase, right? So unless you want to access your Postgres objects using, double quotes with the object name, right, you need to add transformations to convert the metadata over to lowercase. So the way that we do that is we're going to add 3 transformation rules. First one is going to be at the schema level, right? And we're going to pick our schema, and we're going to say convert it to lowercase, right? Make lowercase. Then I'm going to add a similar rule for the table. So the table names will be created as lowercase, right? And then I'm going to say make lowercase. And then the third and final transformation rule for the column, you tell it, okay, we're in the DMS sample schema. The tables, we've already specified we're only migrating the underscore data. I could be more specific and go under data for only these tables. I want all the column names to be made to lowercase, okay? So now I'm ready to create the task. So I'm going to go here, create the task. It's going to take just about a minute to do that. So let's just take a look at a similar task and what you can see at the task level. All right. So here's an overview of a task that I've already created. So it gives you, okay, I'm doing a full load. Here's my source. Here's my target, right? I had run this, so it shows the status is load complete. With the new task, it'll show ready, right? Then there's other things. For that particular run, we're going to be recreating this, right? So I migrated these tables, right? It shows that the table names, it was completed, right? And here, since we were doing a full load, it shows the number of rows that were created. If I was doing CDC, it would show some data under insert, updates, and deletes, okay? So it gives just a way to see what had been going on. If I click over here to CloudWatch metrics, it's just ways that if I'm running jobs, I can monitor what's going on at any point in time, okay? So let's just jump back and see that our task is ready. So what we want to do is we click on this task, And again, we haven't started this, so if I did the same thing and looked at table statistics, I show that there's nothing happening. It says, hey, run the task in order to see some statistics. So I'm going to do that. I'm going to click start, and I'm going to start my task. Okay, now you see this is going to refresh every once in a while. You might want to sit here and hit the refresh button. Right, so the job is starting up. Everything's initializing. The next state is going to show it that it's running. Right, so and this can happen pretty quick. If I go into this task, and let's say we go view logs, once this comes up, you're looking at the logs live, right? So you can see, all right, so there's a bunch of tasks that steps that have been occurring for this replication task, right? So here we actually see, before the page even refreshed, it's showing me that some load has been finished. So if I jump back to database migration service and I look at the table statistics, hey, here's my, verify I'm in my webinar task 2 that we created live. Here's my tables, and here's the number of records that were loaded. And now I can verify that, right? If I go into my Postgres database, just using the dbeaver tool. So I'm over here. Let's go to my Postgres session here, and I want to select count star from dbms, the MLB data, which had 2,200 and something records on the Oracle side. I run this select count star, and now I've got 2,230, and I can do the checks on the other tables and see that my DMS data load worked properly. All right, so that's it. That's a simple use case of how you use SET to do the assess, the conversion, and then using DMS to migrate the data. All right. Another thing that you want to consider when you're doing these conversions is that you've got your source databases, and it's running on machines with certain hardware specs, CPU, memory, and everything. And the common question is trying to figure out what is the target AWS RDS instance size going to be. In order to determine that, there's a lot of factors that are involved, right? It can be as simple as just mapping existing to new, but of course in the new environment there might be faster CPUs, so you want to take that into consideration. But more importantly, you want to look at things like utilization. So in its totality, the information you want to look at to figure out sizing is the number of CPUs that you have on your source system, the number of cores accessible if you have threading turned on by any chance, the amount of RAM available, and how much memory is used by that database instance, right? So you can map to appropriate sized memory instances in the AWS world. IOPS needed, right? There's different levels of IOPS you can get with different storage options within the AWS environment. And then, as I just mentioned, the utilization is really important. If a machine is 100% utilized, then it's going to be a very similar, mapping to the target platform. Of course, depending on what the target is, you may have to increase some CPU or memory depending on how the new target database uses those resources. But if you have a system that, your utilization shows it's only, 50%, it's installed on a shared server, when you size the AWS instance, you're going to size it to be, roughly 50% smaller than that source hardware, so you don't have underutilized resources. So, hope you enjoyed that demo. With that, I'm going to pass it back to Sandeep to wrap up the presentation.
Thank you, Craig. Appreciate it. That was super exciting to kind of watch that demo, going from an Oracle to Aurora using SET and DMS. So let's talk about some next steps. So now that you've kind of seen this in action, right? Let's figure out, in terms of how we can take those next steps forward. So the first thing we'd like to, suggest is to identify some databases that you have in the environment to migrate to AWS. Use the WQF or the workload qualification framework that Craig talked about, and identify some workloads based on that framework that you want to migrate to Aurora. Then, once you identify that Oracle set of Oracle databases, download our tool, especially the schema conversion tool. It's available, free of cost on the AWS website, and download that tool and run it. And point that tool to the source database and really run the assessment. And that assessment tool, like Craig showed you an example, will produce a customized report for that specific Oracle database. That'll really tell you in terms of what is that level of complexity involved in migrating that database over. How much of that schema and objects can get converted automatically to Aurora Postgres, right? So run that tool, review the report, and then use the combination of both SCT and the database migration service DMS for the migration. So with that said, there's a couple more things that we just want to highlight before we open up our Q&A. There's a ton of resources available on our website to go deep into a variety of the tools that Craig touched on, SCT, DMS. If you want to learn more about the different database options that I talked about earlier in the presentation, right? Go to our purpose-built databases page. There's a ton of information there on not just on Amazon Aurora, but also a variety of different database options that we have to offer. Database migration service resource page has a ton of kind of documentation, tools, tutorials on how to use that service in more detail. If you have a specific opportunity that you would like our help from, go to the database freedom page. There's a lot of great resources and migration playbooks there that you can leverage, but there's also a way for you to request help and connect with us on your specific project. So I encourage you to touch on that as well. The variety of different partners, consulting firms that we have worked with around database migration, those partners are listed on our partners page, and as I mentioned, there are a ton of resources, both digital as well as collateral that you can access on our migrations pages. So with that said, let's open up our Q&A.